this talk is called History of Haters. And first I'll just quickly introduce myself. My name is Stopa, founders of Instant. Before Instant, I worked at Facebook and Airbnb. I really liked web development when I was like 12 years old, and now I'm 30, so here we are. The plan for this talk is I'm going to talk about three things. I'm going to talk about imposter syndrome, which I think plagues like everybody in programming. And then I'm going to talk about a history of computing, which is kind of also a history of imposter syndrome. And then I want to talk about the future of programming itself. So let's get to it. So the first thing I want to talk about is this idea of real coding. You know, I think all of us have had this experience where, you know, there's some group of people who are coding, and then the other group says, that's not real coding. You know, that's some baby stuff, right? But I think this is actually a long tradition. You know, our entire field has had this problem of feeling like imposters. And you can sense by just looking at the titles we use for our own system. So for example, computer science, right? That's an interesting title, but I don't think if you asked Einstein and Niels Bohr whether making a to-do app was science, right? And the reason is because, you know, science is experiments and hypotheses, and you're trying to understand some ground truth. I don't think making a to-do app is quite the same thing. So if it's not computer science, what is it? Is it software engineering? I think you can make an argument that there's an aspect of software engineering, but if you ask Nikola Tesla what we're doing, again, I think he would think like, you know, bridge building is a little bit more like software engineering, and a little bit like engineering, and software engineering is not quite it. Like Spotify doesn't feel like something that Nikola Tesla would approve of as an engineering project. So why am I saying these things, right? I'm not just trying to be a bummer, right? What I want to do is I want to go and I want to try to think about new models. Like, what are we actually doing? And before we discuss the future of programming, maybe it'll make sense to go into the past. So how has programming been changing, right? This will be a history of people critiquing the next generation. So the very first kind of thing that looked like a computer was this thing called the MIT Network Analyzer in the 20s. You can see it looks quite daunting. But what it basically did was it analyzed AC circuits. Like, why would you need this? Because, you know, you have these giant, big circuit projects that you're working on, and you want to make sure that if there's any low voltage, you can kind of figure that out. And what they would use this machine to do is to basically simulate that. And that was like a huge innovation. But it was single purpose. The only thing it could do was to simulate circuits. So what would you do if you had different problems? Well, you know, you'd be out of luck. So another guy had an idea and said, wait a minute. And he built this thing called a differential analyzer. And what that could do is it could take not just equations for AC circuits, but it could take any kind of differential equation and run it. Now, why would you have to do that? It's because of bombs. So, you know, if you're trying to throw a bomb at somebody, you're going to have a table of how to throw it, and this is what this was able to do. Now, the win here was it was multi-purpose. It wasn't just one equation. You could actually just change the machine by changing up the bolts, and then you'd get another equation that you could run. At this point, there were no haters. You know, if you ask Nikola Tesla, what's this guy doing? He's an engineer, right? But things changed, because when you look at that, you know, we were using screws and bolts, and that's kind of error-prone and a little bit slow. So the ENIAC came around, and it replaced the bolts with electricity. It could still run any kind of equation, but the way to change the equations was you would just change the plugs around. And as soon as this happened, we got our first round of haters, because it just didn't feel like engineering anymore. Like, you know, changing around screws, it felt a little bit more real, but changing around wires, like that doesn't feel like real, right? So the first critique we got was digital engineering isn't real engineering. But as soon as you got electric systems, then suddenly you could do a lot of things a lot faster. More problems became tractable. People began working on more things, right? And eventually we got this thing called the UNIVAC, where there was a new idea, where instead of changing around the plugs, they thought, wait a minute, what if we just encode instructions in the beginning? And to change an equation, you don't have to change the plugs anymore. Now, the way that you would encode instructions was using object code. So it looked like this. You might imagine the person who had to work on that would be extremely frustrated. But thankfully, it wasn't this annoying. Usually there's like a table at the top. It says like the location, operation, the operand. And to make life easier for themselves, they would have a little comment section on the paper so that they could understand all these code that they wrote, and maybe other people could eventually understand it too. So one person, first I just have a question. Can you guys guess what this is supposed to do? Any guesses? This is just a squared plus b squared equals c squared. But you can see it's quite difficult. This actually had a bunch of other problems. Not only is this difficult, but these operand codes are only for a specific machine. So if you had to move to a different machine, you had to learn this whole thing all over again, right? And it's literally just numbers. It's quite annoying. So this led somebody to have an idea. Like, wait a minute. What if we just take the comments, right? We move and we use like a program that can take the comments and write the machine code for you, right? So that's when COBOL was invented, right? And you can see it quite looks like comments on that table, right? As soon as this got invented, suddenly we got a whole new slew of haters. Because if you remember, these computers are giant, and they were worth about like 1 or 3 private jets at the time. I put up a little laptop there just so you can sense for scale, right? So what they thought at the time was, wait a minute, like, why would you get a compiler to write machine code? Because first, if the compiler makes any mistakes, that's very expensive on this machine. And second, why would you even help humans in the first place? Because human labor was cheaper than running the machine, right? So they were very confused about this. But turns out once you can write programs, you can write a lot more problems. It's a lot more tractable, right? So people kept on going. Now you might wonder, how did people write programs in the first place? Like, how did this go? What you do is you write them on this punch cards, right? But you couldn't just you didn't just like run it yourself. This wasn't like a giant building where somebody was working there, and then you would give your punch cards. And then the next day, or if you're lucky, like the next day, you would get back the response, as long as you had no errors, right? So that's very annoying if you can imagine the kind of programming you had to do that. And one guy was like, wait a minute, this is not for me. What I want to do is I want to actually interact with my program, right? I want to be able to just write some code and then see the response right away. So he had this idea of time sharing, where you would take little terminals and they would connect onto this machine. And this changed everything, right? Because previously, the main kind of person working on this was like a government employee or a military system, right? And then it got changed to this guy, right? So suddenly, instead of just building ballistic tables, you could build things like space war, right? When you're using computers in this way, you start using them in very different ways. Like literally within the first month, the programmers who started using time sharing would start chatting with each other, right? Who would have thought that you would use computers to do that, right? This got a whole new generation of critiques, because they thought computers are for serious work. What is this space war, right? And why do you even need to interact with a computer, right? You should just write your code and give it. But as soon as you interact, you get a whole new slew of kind of programs that you can write. And things started changing even more, right? These guys made a microchip, and computers started getting smaller. So look at this computer. Do you guys know what this is called? What the category is? This is called a mini computer, right? It's the size of a fridge. So now you can only imagine what they call this computer, right? They called it the micro computer, right? So once you got these microcomputers, you got a whole new slew of haters too. They think, wait a minute, these computers are for like solving big problems. Why would you need a computer in your home, right? A personal computer, it would be like saying you need a personal nuclear reactor, right? Like, what do you need that for? Well, it turns out you need it for lots of things, like Microsoft Office and Doom. And suddenly, right, something that had a super small industry just started exploding and became one of the most important industries in the world. Lots of money and lots of really cool software gets written, right? But things kept on going. So around this time, so now we're in the 80s, right? How did people write programs? So let's just consider the most basic one. We all raise your hands. Who knows the Fibonacci sequence?
By heart?
All right, by heart. 2040. Which one is it? All right. So we know the Fibonacci sequence, right? It's a simple rule set. I'm just going to look at how it would be like to write this. If you were to use COBOL, this is what you'd have to write. I think a mathematician would be very unhappy about this. Especially with very verbose words like perform, from, to, by, one. And then, now you have something like C, which is pretty good, right? But it's not that great, right? You had to, the best you could do basically was to write C because you were constrained into writing desktop applications. And at that time, what that meant was you had to write C. Well, somebody had an idea, right? The internet was coming around. And suddenly, like, instead of writing desktop software, you could have a server, right? And then you could just use the internet like a tunnel and you write whatever language you wanted in your server, right? So instead of using C, you could use something like Ruby and get this all done in one line. For this, the people who will notice this, that Ruby program is very, very inefficient. But that's kind of par for the course, right? The cool thing, though, is you can do so much more when you have this, right? But of course, you get a whole new set of critiques. The language that Ruby was categorized as was called a scripting language. And you can already see, like, a scripting language. Who builds production software with scripting languages, right? Suddenly, okay, people are saying web-based software isn't real software, right? Well, things kept on changing, and you got Google Docs and Gmail, and suddenly, like, most new software gets written is server-based software in the 2000s, right? But things kept evolving. You have this server, but if you're building a to-do app, what do, right? You talk to a database, you get who you are, you figure out what route you're on, right? And then you render a page. So this is the exact same thing that you have to do for to-dos and docs and bank statements. Right? So somebody had an idea, what if we kind of generalize this, right? And they came up with Rails. And this, again, made programming so much easier. So many more people could program. But of course, this came with new haters. Web-based software isn't real software. And then, hey, if you can't build servers from scratch, like if you don't know if you don't know that underlying technology, maybe you don't know what you're doing. But of course, the people who use that ended up building GitHub and Zendesk and Airbnb and Shopify, and certainly quite a few billion-dollar companies using these abstractions, right? But things kept on changing again. Well, early on, we only had one machine, right? So you could build a web app and it would work, but then we got the iPhone and the Android, right? And those have kind of different constraints. The internet isn't always on. The client side is actually a lot more important. So what would you have to do in this case, right? If you wanted to write the Fibonacci sequence again, it's a little better than C, I guess, but not really, right? You're back to the old days, right? So somebody had another idea, right? What if we can just use the language we used for the internet and then make it so that it works for all of these at once, right? That's pretty cool. And immediately you got like a new round of haters, which would say things like, hey, like JavaScript apps aren't real apps. What you gotta do is you gotta know the thing underneath, right? But suddenly, a lot of JavaScript apps are real apps. And most apps now are JavaScript apps, right? But things kept on changing even more. So, you have Rails, but now the server kind of broke, because if you're going to have different machines, you can't really render on a server anymore, right? And because the constraints are different on different clients, clients also become a lot more powerful, right? Web browsers can run WASM. You can start moving some of that logic onto the client. So there's a whole new suite of abstractions for this stuff that kind of get extracted out. I wanted to be like, this is a talk with Expo and Instant, so I used those logos. But of course, there's React, there's Firebase, there's Electric, there's lots of interesting companies attacking this problem where they realized, wait a minute, the rendering layer can have its own special thing, auth can be its own special thing, queries can be its own special thing, and people can mix and match and use them as they want, right? But now, of course, you'll get a new set of haters that say, hey, if you can't implement auth by yourself, if you have to use an API, then you're not a real programmer, right? But of course, you can guess now what the next problem is. You could write this code yourself, or you could just ask ChatGPT, right? And of course, you'll get a whole new round of haters about that. So my question is, why? Why does this keep happening? Why is it that there's some group that thinks that whatever the next group is doing is not real programming? Why is this pattern that's been going on since the 1920s? I think it's because of a few reasons. But the first reason I'll say is I think there's a few ways to approach becoming a master at something. One way is you learn all the fundamentals first, right? And then you do the thing. But another way is you just do the thing, and then you'll learn the fundamentals along the way. And both of them are valid strategies. But whenever you do the thing first, it kind of feels off in programming, even though it's the most effective way, very often the most effective way to do it, right? You can see, if you're writing a book, like you're a novelist, right? Nobody says to a novelist, you have to learn all the structures of grammar and all the ways that all other books are written before you write yours. You could just start writing. Maybe your book is not so good, but eventually it will be good, right? And I think this strategy actually works really well for programming. And what this strategy lets you do, right, is there's a history of abstractions, right, that let more and more people build things. So originally, right, if you wanted to make a really cool 3D game, you would have to be John Carmack or Tim Sweeney, right? And that's amazing. Those programmers are amazing. But not everybody is like that. And does that mean that only the only kind of games that we want to play are games that John Carmack makes? No, right? So when people create these abstractions, a lot more people can make more interesting things. And even if you have another John Carmack, right? Think about it. Isn't it great that there's this underlying tool that you can rely on so that now you can put your effort on the next level and deliver value at a higher level of abstraction, right? And this is what kind of using the history of these tools are getting us to build into. Now, you might be wondering, even at this moment, while you're about to build a next thing, you might be considering to yourself, what do I use, right? And the imposter syndrome is going to hit, and you're going to think to yourself, oh, okay, I'm going to be a serious programmer now, so I can't use this and this new software. What I'm going to use is the tried and true, the thing that is safe, that if somebody looks at me and they'll say, that's a real programmer, right? But if you've just seen the history of what happened, what's actually going on is eventually the things that you're going to do that sounds like a little crazy and on the edge is going to become the default. It's going to become the real programming of the future. So by just kind of following your intuition of how can I get my product out to users, you'll end up living in the future. So that's my talk.